And here we go. The first thing we're going to look at is our basic trigonometry. So we say, oh, basic trigonometry. Okay, that's not so hard. I have to use SOHCAHTOA. So I know because I've got two triangles here and they're both right angle triangles. They've got that right angle triangle symbol right there. They got that 90-degree angle. I'm going to use sine, cosine, and tangent ratios. So let's do that. For our first one, I have a look at it and I say, okay, I'm looking from this angle of 41 degrees. That means this is my opposite. That's my hypotenuse and that's my adjacent sides. I notice that my adjacent side, I don't seem to know it or want to know it, so that one's out. My opposite and my hypotenuse sides are the ones I want to use, and that means sine ratio is what I want. So I'll say sine of 41 degrees. Yikes, that doesn't look like a 4. Here we go. Sine of 41 degrees is going to be my opposite. That's 12 over my hypotenuse. That's my unknown. Remember that these ones are a bit tricky because our unknown's on the bottom. Got to multiply both sides by x to move it up over here and divide both sides by sine of 41 to move that down over there. We're going to end up essentially with our x and our sine of 41 switching places. So we divide those out, and that's going to be 18.3. So as we go through this, I want you to be doing an internal checklist. So I'd like you to think to yourself, self, can I do that? Can I do that without help or assistance? Am I okay with that? So you don't have to say it out loud. You don't have to post it in the chat. I just want you to assess for yourself. Do you feel like you can do that? Here's our next one. We're finding an angle. So the angle is our unknown. I called it x. I could have called it theta, but I called it x in this case. There's our opposite, there's our hypotenuse, and there's our adjacent. So I'm going to say, okay, I know my adjacent and I know my hypotenuse, so those I'll use those to find my angle. Xavier, yes, I am recording this. Good question, thank you. So I'm going to say the sine of that angle is going to be my adjacent, that's 12, over the hypotenuse, that's 72. Sorry, not sine, it's cosine. Because that's adjacent over hypotenuse, it's cosine. So x is going to be the cosine inverse of my adjacent over my hypotenuse. And when I plug that into my calculator, I'm going to get to the nearest degree is 80 degrees. So please ask yourself, can I do that? Can I find a side? Can I find an angle in a right angle triangle using SOHCAHTOA? That will be on your test tomorrow. Here's my next one. I'd like you to look at these two triangles, and I'd like you to try and identify what trig tool you're going to use to solve them. Okay? Don't say it out loud yet, but I am going to ask you in a moment to try and identify the trig tool that we would use to solve them. All right, we're going to start with the one on the left. Without pressing enter, I'd like you to type into the chat, what trig tool do you think we might use to solve this? So I'd like you to type into the chat, but don't press enter for the one on the left. Okay, please hit enter. What do you think? What should we use for this one? Thanks, folks. Here come our answers. Looks like we're all on the same page. We're thinking cosine law. Lakin added an element here which I really like. Lakin added in side angle side. Side angle side. So telling me, okay, that's how I know it's cosine law. So yeah, cosine law is the one we want here, and it's because we know side angle side. Two sides and the angle that contains them. Great job. Okay. If you said another one, that's okay too. It just means now you know this is an area where you need to do a bit of practice, right? So let's do cosine law. Cosine law comes in two forms, which you have written down, of course. There's the finding a side and there's finding an angle. In this case, we're finding a side. So we're going to say this is kind of like Pythagorean theorem. But it's got this extra bit on the end. And of course, I make sure that the side I want to know is across from that angle that I've got in there. So I know those have got to be matched up. Okay, now we're just going to plug away. Let's get through some answers. So we got, I'm just going to kind of go through this quick. So I'm going to say, okay, I got to take the square root of all this stuff. 6 squared is 36, 14 squared is 196. And 2 times 6 times 14 times cos of 23 is 154.6. So that's going to be, when I add all those up, root of 77.4. And so that's going to be 8.8 when I round it off to one decimal place, 8.8 meters. That's my cosine law. Okay, my one on the right side, what trig tool am I going to use for that? Type it into the chat, don't press enter. Don't press enter, just type it into the chat and wait. So our one on the right, what are we going to use for that? Type it into the chat and I'll let you know when it's time to hit enter. Okay, you can go for it. Let's hit enter and see what we got. Chris, I actually liked it better when you wrote some law, because that's also correct, some law. But yes, I figured that you meant to write sine. Thanks. So it looks like sine law is our most common answer. Again, if you weren't sure, that's okay, but that means now you know you got to figure this out. Oh, thank you, Sam. Great question. Are we looking for x or theta? In this case, I actually want to look for theta, so I'm going to cross that x out. But that is an excellent question, because that could change how we would approach this problem, right? So in this case, Lakin, you said sine law first to find the angle, and then you would use cosine law to find the side, and that's exactly right. So thanks, Lakin. That was well done. You'd use sine law to find the angle, and then you'd have to use cosine law to find that side. But I just want to find the angle in this case. So let's do that. We'll set up our sine law. I know I want to put my unknown on the top, and I always need to do the sine of the unknown. And of course, that's going to be over the matching side that's on the other side. I could have had my sides on top, but if I have my unknown on the bottom, it makes it more difficult to complete. Now here's my other matching pair, 41 degrees and a side of 27. So I'll put those in. Great. Now I'm going to multiply both sides by 35 to move this 35 up off the bottom. That puts it up over on the other side. I have real trouble with my 4s on this writing tablet. Good thing you folks are so patient with me. Okay. So I work that out, and I end up with 0.8504. And then I take my sine inverse. and I get some angle, ends up being 58, and round it off to the nearest degree, which is what you should do unless I ask otherwise. Okay, so cosine law, sine law. Two examples. Take 10 seconds right now and think to yourself, how do I feel about those? Am I feeling really comfortable? Am I feeling a bit shaky? Do I need practice on sine law, but I'm okay with cosine law? Give it some thought about where you're at. Now, lots of people talked about the dreaded word problem. The dreaded word problem. And that's something I anticipated. That's normal. It's normal. Every group of students I've ever taught, word problems get hard because there's more context. And in reality, the more real a problem gets, the more context there is, and the more challenging it gets to filter out the noise and figure out what you really need. So that's okay. That's normal. If you have problems with word problems, you're just like everybody else. I'd like you to read this over. This is a tricky one. I'd like you to read this over, and then I'm going to ask you to try and make a drawing. This is actually a three-dimensional drawing. So it says, Caitlin wants to calculate the height of a tree on the opposite bank of a river. So she's on one side, tree's on the other side. To do this, she lays out a baseline of 100 meters long. That means she walks along the edge of the river 100 meters and puts a stake in one spot and a stake in another spot 100 meters apart, and measures the angles along the baseline to be 80 and 27. So that means the angles between the riverbank turning all the way to pointing towards the tree on the other side. Okay? So those angles between the riverbank and a line pointing to the tree are 80 and 27. And then from the corner with an 80-degree angle, now we're going up an angle of elevation to the top of the tree of 26 degrees. I'd like you to just try and sketch this out. It's tricky. Give it a try. You got 63 seconds. Go for it. All right, so you've got your little picture. I want to show you what I've got here. There's my tree on the opposite side of the riverbank, and I put H for the height of the tree. I've also got a little 90-degree angle there. And I go down across my river. Here's what that's going to look like. So I've got my baseline of 100 meters, where Caitlin walked back and forth. The lines that go across the river to the tree, these imaginary lines, have angles of 80 and 27. And then standing and looking up to the top of the tree has an angle of elevation 26 degrees. And I want to find the height. Tricky. So I've put in some things for the stuff I don't know. I don't know that angle theta that's across the river there. So Sam, you could form a straight line, but then you can't calculate the height. Thank you for letting me know, Sam. I've been talking to myself for like 30 seconds here. So I said, well, I was muted that whole time. Boy, I think I'd get used to this. I said when I was muted that whole time, this is what my drawing is going to look like. So the reason you do the baseline is because it's hard to measure across a river. Because I guess you could like get someone in a boat to take the boat across the river and you like pull a tape measure with them and hope it doesn't fall into the water and stays mostly straight. And that would just be really hard. So instead what you can do is you can just measure something on your side of the river and then just use an angle measuring device like a clinometer to measure the angle between the riverbank and turning all the way to that tree from those two stakes you put in the ground. And then you can measure how high you have to look up to sight the top of the tree. And that way you don't have to cross the river. You can tell the heights of things from a distance without ever having to get actually close to them, which can be really useful for things you're not able to get close to. And this is actually how you can find the height of a mountain from a distance as well. This same technique will totally work. So this is a technique that's actually quite useful in terms of finding heights of things without being next to them. And this is essentially how tools that would do that on phones and things like that. Now there's apps that'll do this. That's how they work. So I say to myself, okay, I got some stuff listed here. I've got my my angle theta right here. So I know the two other angles in that triangle, so that means I could find that third angle theta. I also put the side right here, because that side would be really useful to know, right? Right now I got this 90-degree angle triangle. This is a right angle triangle that goes between my side of the river and the tree. And I know the angle of 26 degrees. If I know one of the sides on that triangle, I can calculate anything else about that triangle. So if I can get that side labeled X that's in red, if I can figure out that side, then I'll have enough information to figure out the height of the tree. So let's do that. I'm going to change my view here. So I got places to write. And the first thing I'm going to do is figure out that angle theta. So that's just that's 180 degrees minus the other angles, right? So I'm going to go 180 minus 80 minus 27. That's going to get me 73. So that angle up at the top of this flat triangle that's laying on the river, that would be 73 degrees. Now I want to figure out that side X, because that'll be really useful to me. So I'm going to use sine law for that. So I'll say X over the sine of 27. That's the angle across the way. So X and 27, let's match those up. That's going to be equal to the side I do know, 100, and it's across from an angle of 73 degrees. So I worked that out. Let's multiply both sides by the sine 27. And that's going to give me that side X is going to be 47.47. Now normally I would round this off to one decimal place, but I want to be like extra exact here because this is not my final answer. So I'm going to leave an extra decimal place in there and then I'll round off my final answer. Now I've got this triangle with a base, it's a right angle triangle, it's got a base of 47.47 meters, it's got an angle of elevation of 26 degrees. I can use my basic trig. Now, tangent ratio will give me opposite over adjacent. The opposite is the height. The adjacent is the value of x that we just calculated. So that's the one I want. So I'm going to say tangent of 26 is opposite. That's the height over adjacent. That's side x, 47.47. So to get h by itself, I'll multiply both sides by 47.47. That's times the tan of 26 degrees. And I fire that into a calculator, and I see what I get. That's 23.2 meters. It's always nice to put a red box around my final answer. That makes it super clear. And I'll do a little therefore statement because it's a word problem. I'll say therefore the tree is 3.2 meters tall to show I understand the context. Okay, so tricky one. The hard part is making the drawing. The second hardest part is recognizing, okay, what do I actually need to solve this? The easy part is actually doing the sine law, figuring out the angles by subtracting from 180, doing the tangent ratio. That's the easy part. So word problems, they are a pickle and they're tough, but we do need to add that context and be able to piece it out. And this technique you see is a real technique for finding heights of things. Quite a useful one, actually. If I had you folks in person, we would actually like find a good spot and we'd go outside and we'd use this. Okay, here's one. Given the point 8, 15, find the exact values for all 6 trigonometric ratios. Ugh. What does that mean? All 6 trigonometric ratios. Well, that means sine, cosine, tan. And then the reciprocal ratios, cosecant, secant, cotangent, which are just sine, cosine, tan flipped. So if we can get sine, cosine, tan, we just flip them. That'll be easy. So let's figure it out. Let's see. This side is 8, and this side is 15. Now, of course, if I'm doing sine, cosine, tan, I'm going to need the hypotenuse as well, right? So let's figure out the hypotenuse. We usually call that r in things like this. We say the good old, lots of pirate jokes to be had from that. So r squared is equal to 8 squared plus 15 squared. So I'm going to cut out some of the work there and just do the square root. So I'm just using Pythagorean theorem, which I can because it's a right angle triangle. So it looks like r is going to be 17. So I'm going to add that to my picture. Those are my 3 sides to my triangle. So now let's do sine, cosine, tan. Sine theta, cos theta, tan theta. Well, sine theta is opposite. It's 15 over hypotenuse. That's 17. Cos theta is adjacent. That's 8 over hypotenuse. That's 17. Tan theta is opposite over adjacent. Good. Now my reciprocal. Cosecant, secant, cotangent. Now I need to flip my ratios. So I'm just going to take the ones on the left and I'm going to invert them. I'm going to flip them. There, all done. Okay. So now we actually have 6 ways of finding the angle. That's a lot. I want to do a couple of these, and then I want to talk a little more trig identities, and then I want to give you just a bit of time to get to work, because there's some stuff I'd like you to practice, and I know you just need time. Time to pick away at it, time to work at it, time to get prepared. So let's try a couple of these. These ones are quite tricky. These ones are quite tricky. So it says determine the exact values for the following, sketch the angle. So for the 11M class, you won't have to do the exact value stuff because special triangles and special angles aren't in your curriculum. Although you will see them again, so I'm glad you'll have seen them. You'll see them again in grade 12 math courses. Okay, so secant of 150. Ugh, okay. Well, secant of 150 secant is going to be, well, let's see. Secant is related to cos, right? Because secant is just 1 over cos. So let's think to ourselves what that's going to look like. Secant is hypotenuse over adjacent. Secant is hypotenuse over adjacent because it's cosine, but it's the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Now let's actually draw this on here. Let's draw an angle of 150 degrees. Let's see what this looks like. Here we go. 90 degrees gets us to here. I'm going to keep going an extra 60 degrees, and that gets us to here. So there's our terminal arm right there. And so that's 150 degrees. That's an angle of 150 degrees. Now you might have figured out already, you might have picked up on this, that our related acute angle, which is in here, if this thing is 150, how much is left over for the 180? Well, it's 30 degrees are left over. 30 degrees are left over. And if that's 30, well, up here has got to be 60 because it needs to add to 180. Oh, and that's one of our special triangles. Hooray! So we know with our special triangles, across from the 30, it's a 1. Across from the 60, it's a root 3. And the hypotenuse is a 2. We say it's a 1, 2, root 3 triangle. Of course, the 1 is on the positive y axis. It's above the x-axis. The root 3 is going to be negative because it's on the negative x-axis. So I say, okay, secant is hypotenuse over adjacent. So when I'm looking at my related acute angle, my hypotenuse is going to be 2. And my adjacent side is negative root 3. And if I wanted to rewrite that a little neater, I could multiply it by root 3 over root 3. And I could just have it as 2 times root 3. That would be fine too. Both of those are correct. Now you say that's a weird looking thing, but if you plug that into your calculator and see what you get, and then you plug in, well, you can't plug in secant 150 because most calculators don't have a secant. But if you go 1 divided by cosine of 150, you'll get the same answer. You'll get the same answer, but this is an exact one. So, whew, that's tricky. Let's try one more of those because these are a bit tough. This one's got a negative of 135 degrees. So let's remember negative means we're going this way. That would be negative 90 to get us to here. Negative 180 would get us to the next one. We're not quite there. So it'll get us to here. So we're going the wrong way, 135 degrees. So question is, what does that leave as our little related acute angle here in this triangle? Well, we're 45 degrees short of making it to 180. So that's a 45. And that means this other one here is also 45. So that's one of our special triangles, right? That's our 1, 1, square root of 2 triangle. That's one of our special ones. I know this one is going to be negative because it's on the negative x-axis. This one is going to be negative because it's down here. So I'm going to have those two as negative values. Cosecant is just like sine, but it's flipped. So it's going to be hypotenuse over opposite. It's just like sine, but flipped. Well, my hypotenuse is root 2. My opposite is negative 1. So that's just going to be root 2 divided by negative 1. That's just going to be negative root 2. So that's tough. But our goal when doing this is first look at the angle, draw it, see what kind of acute triangle it makes when we connect that little triangle to the x-axis, and then think about what cosecant or secant or whatever means. Does it mean, in this case, secant was hypotenuse over adjacent? Cosecant was hypotenuse over opposite. What does that mean? And then we'll have a look at the triangle and use the sides of the triangle. Tricky stuff. Okay, I think the last thing I want to do before I just give you some time to work is let's do another trig identity. So Sam, you said when looking for exact values, what is it we're looking for? So when you're looking for exact values, you're basically finding what you would get when you type that into your calculator, but not a rounded off decimal. Oh, so specifically with cast, you're just looking for the value of that. So for example, with secant 150, you can't type that into your calculator because your calculator doesn't have a secant button, but you could type in 1 over cosine 150. So you can plug that into your calculator and you'll get an answer. You'll get some number. And that some number will be a long string of decimals. But what it is it's equal to this thing right here. So when we're doing it with an exact value, it means we don't have a string of decimals. Yeah, so the degree of the rotation. Yeah, but we know the degree of the rotation is 150. We're saying what's the secant of 150? Similar to saying what's the sine of 150 or the cos of 150 or the tan of 150. Means when we've got an angle, it makes a triangle, and we're dividing two of the sides by one another. So we're getting a ratio. I know that's kind of obscure and complicated, and it is, but you have to think, secant of 150, that's just a number. It's just a number. And instead of having it as a string of decimals that we round off, we want to be able to get it as an exact number, which means we need a triangle that's got 30, 60, or 45 in there. Okay, let's try and figure this one out. This one's a bit tricky. I can actually go with either side. So I'm going to do the left side, and then we'll see if maybe we want to do the right side as well. So we got our nice little table here, left side and right side. Let's start with our left side one. Okay, we got secant x plus 1 over cotangent x. I used x's instead of thetas. I could have used thetas for this, but you can use x for an angle too. It's fine. Because the place I grabbed this from used x for angles. So I say, okay, let's have a look at this. Secant is 1 over cosine. That's what secant is. It's just 1 over cosine. Not equals, pardon me. And cotangent is 1 over tangent. Or sorry, it's 1 over cotangent, so that's just tangent. Because 1 over cotangent is equal to just tangent. So, okay, I've done my first step. Now I got to add these two together because I know they're going to be one term. So here's what I'm going to do. I'm going to take tangent and I'm going to turn it into sine x over cos x. That's one of our trig identities. Tangent is sine over cos. Now I can add them together. They got the same denominator. So I'm going to end up with 1 plus sine x over cosine x. And that equals my right side. So I did it. I could have gone the other direction on my right side and got to the same answer. I could have said, okay, 1 plus sine x over cos x. I can split this up as 1 over cos x plus sine x over cos x. And 1 over cos is secant, and sine over cos is tangent, and tangent is 1 over cotangent. So I could have done it on my right side too. This is a tricky one. There's not going to be much in the way of trig identities on the test. There will be a bit. There will be a bit. And they're not going to make them super hard ones, but there will be a bit, and you'll have to play with them. Okay. Sam, you asked for up here the theta and not the beta. The related acute angle and the primary angle. And those are related to one another. Essentially, they'll give you the same answer, which is why that's useful to have one and use it to get the other. Okay, here's what we're gonna work on a bit today. I know that's been a lot. I'm gonna stop my recording.